Morgan runs a personal best marathon. So to use the law of detachment, the hypothesis has to come true. Did Morgan run a marathon?
Yes.
Yes. Morgan ran a marathon. Morgan runs a marathon. They just gave you a little bit of extra information you didn't need. So did the hypothesis come true?
Yes.
So does Morgan need to rehydrate? Yes. This is the law of detachment. Now, is that a tricky one? Yeah, because it's got that middle stuff that you're like, okay, it's not exactly the same as the hypothesis, so we probably said it was false. But this is the law of detachment works. It's valid. Law of detachment says so. Now, it did look like everyone got number 2 right. Number 2, it said if two adjacent angles are 50 and 130, then they are supplementary. And we realized that they are supplementary linked up with the hypothesis of the next one that said the two adjacent angles are supplementary. If they link together, we can cut out the middleman and go if two angles are 50 degrees and 130, then they are linear pairs. I think everyone got this one. That was the law of syllogism. And our final one says, if you go watch your team, then you will wear team colors. Now, in order for this to be law of detachment, this next part has to say you watch your team. Does this say you go to watch your team? No. So we cannot use the law of detachment. This one is invalid. Does that make sense? Make sure you're clear on that. Because a lot of us made mistakes. It's okay if we made a mistake on the first one. That one kind of tripped up. But this last one, definitely, you need to be able to get that the hypothesis did not come true. The hypothesis did not come true. Are we sure we don't have any questions? Okay. Then, do we have any quick questions from the homework? Because then we're going to take our quiz right away. It'll be really, really short. But do we have any homework questions? Going once. Going twice. Okay, let's go ahead and clear off some more difficult proof styles. Some more difficult proof styles. Particular ones. There it is. This is our homework. I should get into today's notes. So, the first new proof style we're going to talk about is sometimes we're going to have two variables. And it's going to tell us which variable we need to solve for. So if we look here, we're given 6x minus 2y equals 14. Oh, I should probably write that down. I should probably put given if I didn't already. So our first step is usually given. Now, I start with this, and I have to end up with y equals all of this stuff. Well, we do the same thing as if I was solving for a number or something. Basically, I need to get y all by itself and everything else to the other side. So I have to get everything else that's on this left-hand side. I need to get the 6x. I got to get the negative 2. I got to get all that to the other side. So the way we're going to do that is we're going to start by moving the 6x. We're going to get the y alone as much as we can attached to that number. So I'm going to move that 6x over to the other side. How do I move a positive 6x to the other side? We subtract it. So we're going to subtract 6x from both sides. So that'd be our subtraction property of equality. Now, I want to run through this example because it's really important if you do this example on your own. I think we know what to do with the negative 2, but I'll ask, what do we do with the negative 2? We add negative 2?
No.
So we add 2y?
Multiply. Divide. My bad.
Yeah, because the 2 is attached by multiplication, right? Yeah. So we need to divide by a negative 2. Now, the thing is, when you divide by a negative 2, you divide everything by negative 2. So this negative 6x gets divided by a negative 2. This 14 gets divided by a negative 2. Everything gets divided by a negative 2. Everything. That's how we turn to negative 6x to 3x, because I divided by a negative 2. Negative 6 divided by a negative is a positive. 6 divided by 2 is 3. 14 divided by a negative 2 turns into a negative 7. So everything has to switch signs, but we have to make sure that we're dividing everything by that negative 2. That's the important part of this step. And then we can put our division property of equality. All right, so the key thing is if I divide everything by it. That's what changes when we have another variable in the mix. Okay, the next big concept I want to cover is 2. We spent a bunch of time distributing, right? But if we look here, we went from m equals 1/2 times a plus b. If I distributed that 1/2, if that's what I did, if I distributed that 1/2 to both things, I should have had 1/2 a and 1/2 b, right? Or a over 2 and b over 2. Is that what we came up with?
No.
So they did something else.
They got rid of the 1.
They got rid of the 1/2. How did they get rid of the 1/2 from that side? They used multiplication. What did they multiply by? They multiplied times 2 or the reciprocal. If you want to get rid of a fraction, multiply by its reciprocal, which is 2 or 2 over 1. So they multiplied this side by 1, or not 1/2, but 2 over 1. And which means I multiply the other side by 2 over 1, or just 2. Same thing. 2 over 1 is 2. They're the same thing. That got me my 2m, and it got rid of my 1/2, because 2 over 1 times 1/2 just turns to 1. And we're left with a plus b. But I used the multiplication property of equality. I guess I should probably put my given here too. Now remember, we're solving for b. We're trying to get b all by itself because it says b needs to equal 2m minus a. Is b by itself yet? No. So I need to subtract a from both sides, because a positive a minus a will turn to 0, and I'll move the a to the other side. So by subtracting a from both sides, we're using that subtraction property of equality. We're almost done, except for one small flaw. This is not b equals, this is 2m minus a equals b. Our symmetric property, perfect. I see a bunch of us have that written down. It is that symmetric property that lets me flip. Our symmetric property. Okay, we're going to step it up one more time. Look at our next one. We have f plus g equals k plus 7. And we have k equals f. We're supposed to prove that g equals 7. Now, before we start this proof, let us know what we're trying to do. I'm given f plus g equals k plus 7, but I'm also given k equals f. What I'm picturing is, what was that?
It's not all given.
It's not all given, I mean, it is all given, and we're going to write down the givens. So I'll write down f plus g equals k plus 7, and we'll put our given there.
So we write given for number 2 too?
And we're doing a given for number 2 as well. Yeah, because I have 2 givens, so I'll do 2 steps that talk about the givens. Now we're going to use substitution. Perfect, Bryson. So we're going to use substitution. We can either take this k and put it in place of this f, or we could take this f and plug it in place of the k. I'm going to go ahead and do the same thing I'm doing in all the classes where I'm going to take the f, and I think that's what they did. They took the f and they're plugging it in for k. So we should no longer have f plus g equals k plus 7. We should have f plus g equals f plus 7. And that's what we have, right? And that is, just like you said, that is substitution. And then how did I get rid of the f's from both sides? Did we subtract f from both sides? Yeah, if I subtracted f from one side, so if I'm just like, I just want to move the f to the other side to get the g alone, that would turn to 0, but turns out when I subtract f from the other side, that also turns to 0, and I'm left with g equals 7, and that's our subtraction property of equality. Yeah, don't you have to leave in a second anyway? It is 10:28. Let's look at the next one. The next one's kind of a step up from that one. They give us 3 givens. Well, that's good for point-wise because I can just write given, 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 right? So P equals 3Q, that was given. Our P plus Q equals R, that was given. And finally, R equals 20 is our given. Number 4 is definitely substitution. What did they substitute? They substituted the R. Do we see that? They took that 20 and they substituted into that R. So that's going to give me PQ equals 20. That was substitution. What happened next, though? Suddenly, P plus Q equals 20 turned into 3Q plus Q equals 20. So look what changed. Yeah. So we did another substitution. We said, I don't want P anymore. I want things in terms of Q because we want Q equals 5, right? So I want to get rid of P, so we come back up to our given. It said P equals 3Q. So if you look up there at my given, they took to 3Q and did that. That's all we did. We just got to tell someone we did it. I put 20 in for R. I put 3Q in for P. So now we have 3Q plus Q equals 20, and we used substitution again, just like Jared said. We used substitution again. And now we should just use the rules of algebra. Hey, do you remember what we can do to get 3Q plus Q equals 4Q?
We added like terms.
We added like terms. Can you think of another way? We simplified. Remember, you can put that term on your pink sheet if you want to. On the top, you can just put simplified. Use that when all else fails. We simplified. And then we should have recognized that we just had to divide by 4, right? And we have Q equals 5. And that's our division property of equality. Okay, I pushed through those. Peek at it. So it looked like everyone had given. Correct me if I have that wrong. Our second one is given. There was a little bit of confusion. Now remember, it's how I got to step 3 that tells you 3. Because I had a lot of people put the distributive property because they're going to do the distributive property. This is not the distributive property. This is going to be substitution. And it's substitution because we took that y plus 5 and we plugged it in for the x. Now, I want to pause there real quick. Now, we're going to know that we want to change all the x's to y's because at the end of the day, I just want y's, right? Sometimes we're going to have to do that forward thinking when we don't have all this stuff down here where it's like, oh, I just need y's. I need to replace everything that's not a y with whatever they have equal to. All right. Our next step would be the distributive property because we are distributing that 2. So the distributive property should have happened at step 4. Distributive property, yeah. Yeah. And then we do have to remember this thing. If I have 2y plus 1y, that gives me 3y's. That should be simplify. I would highly suggest you put that on your pink sheet maybe somewhere. Our next step would be subtracting 10 from both sides, which was our subtraction property of equality. And then finally, we would have divided by 3, which would be our divpo. All right, number 10. I think I'm going to skip number 10 because if you could do that last one, you can do number 10. Let's take a peek at number 7 because we have to do the whole thing. 7, we have to do the entire thing. Actually, if you haven't already, do number 6. I want to make sure we can do a number 6 because that doesn't have scaffold. I realize that. Just make sure you have these exact steps. I kind of brushed over. I kind of looked at it. Looked like it was good. Just double check that your steps exactly match mine. So we start with negative 10x minus 2y equals 16. That is our given. And my next step is to get y by itself. So that means I need to get rid of this negative 10x from this side. What's the opposite of a negative 10x? A positive 10x. So we're going to add 10x to both sides. That will cancel that out. And it will move the 10x to the other side. This will now give me negative 2y equals 10x plus 16. And I use the addition property of equality. So we got to be thinking about what we want at the end. I want y by itself, so it wouldn't make sense to move the y's to the other side. Remember, your goal is to just lock down a y and get that alone. Is my y alone yet? No. What's it attached to?
2.
Negative 2. By what property? Multiplication. What's the inverse of multiplication? Division. So we're going to divide both sides by negative 2. Now, here's what I'd make sure I put in my notes, that I divided everything by a negative 2. Notice I put divide negative 2 on every one of these to remind myself that the 10 has to be divided by a negative 2. The 16 has to be divided by a negative 2. So that's going to give me my third step needs to be y equals a negative 5x minus 8. The good news is, even if I kind of messed up this division or something, we could check our answer. And if something's off, we just look back and figure out our answer. And that's going to be our division property of equality. Because I think you started with trying to move the y's over. Yeah. Do you get why I shouldn't move the y? Yeah. Oof, that's too many y's in a sentence. Does that make sense, though? Okay, good. All right, let's just take a peek at... I guess we can take a peek at number 7. 7 just has a unique thing. It's converting from Celsius to Fahrenheit. Good for your science teachers because they like being able to manipulate this formula. So that's why this is on here. So let's start with our given. And let's see if we can work together to figure out how we solve this. Celsius plus 32. So this is definitely going from Fahrenheit. So if I was given something in Celsius, I'd plug it in this equation and it would give me the Fahrenheit out. What I'm trying to do is, I was given a Fahrenheit and I have to turn it to Celsius, so I want to switch the formula. So first we have our given, right? Given. Cool beans. Now, in order to get C by itself, I need to get C alone. So what I'm picturing is, let's lock down C. C's on lockdown. It's going to be the only one we don't move from that side, okay? What's on that side that I want to move over? I have the 9 over 5, and I also have the 32. When you're solving for a variable, you always do your addition and subtraction first. Okay. So we're going to subtract 32. Because remember, if I tried to do anything with the 5 over 9 right now, I'd have to do it to every single term. So if I did something to the 5 over 9, like I multiplied by 5 over 9, which is reciprocal, I'd have to do it to every single term, and I don't want to do that. I want to subtract 32 from both sides first. We always do our addition and subtraction before we do anything else when we are solving for a variable. So that means now I have Fahrenheit minus 32 equals, now we have 9 over 5 Celsius. And I just use the, what? The subtraction property of equality. We will not do the distributive property. We would do the distributive property if I needed to get this 5 over 9 out. So if I started with this one, then I would have to use the distributive property. Instead, remember, we have C just on lockdown, right? C's on lockdown. I lock down C. How is this 9 over 5 attached to this C? Multiplication. So normally we would picture division, right? We would divide by 9 over 5. But if you remember dividing by fractions, you do keep, change, flip. Do you kind of remember that? So when you divide by something, you end up just flipping a fraction, turning it into multiplication. So if you're ever trying to get rid of a fraction, you really multiply by its reciprocal. Do you remember that term reciprocal for fractions? Does anyone know the reciprocal of 9 over 5? Reciprocal. It'd be 5 over 9. That's all reciprocal means. It means flip your fraction. So we are going to multiply this side by 5 over 9. Because that 5 over 9 and that 9 over 5 will cancel out. They turn to 1. That's what multiplying by reciprocal does. If you picture multiplying, it'd be 9 times 5 over 5 times 9. Which would be 45 over 45, which is just 1. Reciprocal, always multiplying works. And then we have to multiply the entire other side. The entire other side by 5 over 9. Which is now going to give me my step 3 is going to be 5 over 9 times the quantity Fahrenheit minus 32 equals Celsius. Now, Isaac, you talked about distributing, right? So now we have to look at what the given is supposed to be. If the given said something like 5 over 9 F equals 5 over 9 times 32, then we'd have to distribute it. Is that what the given tells me to do? Or does the given pretty much look like how we have it already? It's close though, right? The only thing we have to do is switch the two places, right? So we'll use the symmetric property. Oh, I forgot to put in that we use the multiplication property. Multiplication property of equality. And we're going to go ahead and switch the sides. Fahrenheit minus 32. And that is going to be the symmetric. So now we don't need to distribute this because this is the form they wanted it to be in. We're done. Don't go any further because they said end right here. If this was on a test, I might give you a few more spaces to see if you can, confuse yourself. But you have to know when you get to what they say prove is, you're done. You're done. When you get to prove, done. Questions on that? Okay. Let's do one more together, and the last two will be for you to finish off. You already started 10, right? Okay. How many givens do I have? I have 3, so that means I have 3 steps already taken care of for me. So if I'm stuck on the proof, at least I have 3 steps I know how to do. I have given, given, given. Ooh, Belinda's already got that. Nice. All right, so we have x plus y equals z. We have w plus v equals z. And finally we have, ooh, that's a terrible z. There we go. And our third step is y equals w, or w equals y. That is our given. That is our given. That is our given. Eventually, I need to have x equals v, though, right? I need to have x equals v. So that means I don't want z's, I don't want w's, and I don't want y's, right?
Right.
So we got some ways to go. So maybe the first thing we kind of look at is, let's get rid of the z's first. It's up to you. There's lots of ways we can do this. Lots of ways we could do this. But I'm picturing let's get rid of the z first. So now look at the two ways we can get rid of z. Both ways will work, all right? So the first way we could do it is we could take this x plus y and substitute it in for that z. Do you see that? Since x plus y equals z, I can replace any z I see with x plus y. Or I can take this wv and replace this z. Both options should get us the correct answer. Anyone have a favorite way of doing it? No? Okay, then I'll just do this way because I have it up there. Okay? So we'll just go with that one. So rather than having x, so we start with x plus y. But instead of z, we're going to replace it with w plus v. We're going to go ahead and use substitution. I just want to see if I did a more advanced one at all. I will tell you on the answer key, we haven't really talked about the transitive too much. I might have transitive in these places, but substitution works here. We haven't really gotten to the full transitive. I just want to stick with substitution right now. It's kind of the same thing. So why we could have used transitive here is, notice how we have x plus y equals z and w plus v equals z. You can create kind of a chain. So instead of substitution is grabbing it and plugging it in. Instead, we could create a chain. W plus v equals z, z equals x plus y. I created a chain, so I can start with w plus v and end in x plus y. Just like a law of syllogism, we can cut out the middleman. So you could, depending on how you're thinking about it, you could have thought about this as transitive. So I just looked at the answer key. Sometimes I have transitive on those. We can use substitution in those places. So you had substitution, I had transitive. You're fine, because we haven't really gone over the transitive too much. I just want to get to the algebra portion. So I'm going to picture this as substitution. That is straight up taking that and plugging that in there. Are we all clear how I did that substitution? Please ask. Are we okay with that? Are we sure? Okay. Step 5. Well, the only thing I can do in step 5 is I can replace the w with y. Or I can replace the y with w. Doesn't matter which one we're going to choose. They should both work. So notice here it says w equals y. So I'm going to go ahead and I'm going to take this y and I'm going to plug it in for that w. Because if I gave you a fact, you probably should try to use it, right? And if it doesn't work, then we go back and we try something else. So let's see if this works. So I'm going to replace that w with y, which means I'm using substitution. That's going to give me x plus y equals, instead of w, we're going to put a y in its place. Now, just a quick reminder, what do we want our answer to be? X equals V. Do you notice how we have y, the same y on both sides? If I subtract both sides by y, they cancel out, and I'm left with x equals v. And that is my subtraction property of equality. All right, there's two more I'd like you to do on your own, or within your pod is fine too. We're looking at number 9 and number 10, okay? We're going to give those our best shot. We do have till